Okay, so today we're introducing a couple of really cool concepts that are they're starting to get pretty interesting now. So far we've done a lot, with sending out signals. You can light things up, you can turn things on, you can turn things off, you can sense a button. Okay, now you know how to input from the keyboard, so you're building a little library of tools that you can use to make an increasingly complex project. But now what we need to do is we need to take it one step further and actually make it so that our boards and our electronics can actually sense the outside world. Not just a button, yes or no, but how dark it is, how bright it is, how hot it is, how cold it is, whatever it is we want to do, how far away something is. We're going to make it actually be able to do an analog read. And it makes sense when you think about it. You already know digital read and you know digital write. That turns on and off a light and reads a button. And you know analog write. So the only thing left in that sort of block is, well, analog read. Okay, so let's do that. And I've got a template here already called out. So you can see I got my header information, my frame. You guys should be getting pretty good at this. I've got a setup with the begin, serial begin, starting my serial port. And of course I've got my loop, and I've already framed that little function called demo1. Now to build this, you're going to need something like this, okay, or something like this. Both should be in the classroom. All right, these are both potentiometers, oftentimes just called pots for short. All right, they're able to turn. This one's a little stiffer, this little guy right here. So you're going to need one of these, just one. I like these better. If there's any floating around, I'd grab one of these. You're going to need some kind of a standoff. Today I'm going to use one of these tapered ones. And a long enough screw. And, of course, another one of these 3-color wires. Alright? So, that being said, let's hook this guy up. I do want to point out that if we get this focused a little different here, you do want to watch out for the hookup. Okay, that S is where the yellow wire is going to go. Okay, make sure you get that yellow wire plugged into the S on this board. Same with this. If you're using this one, please make sure you get the yellow wire plugged into the S. Okay, so that being said, let me bring this down. I'm going to attach this button again, same way you did with, this potentiometer, same way you did the button, where you're going to run a screw through here, like so, and then you're going to slide over your spacer, whatever it is, and then it's going to be attached. I'm going to attach mine right here, but I'm going to pause it. There's no reason for you to watch me screw this thing in, so I'll be right back. Alright, so now I'm going to take my 3-color wire, and like you noted, you want to put the yellow on the S. So I'm going to plug that in right there. And then I want to plug this other end onto a good spot on the teensy. Okay. Now, we have to use, to do an analog read, we have to use one of these ports labeled A. Okay. And if you're the same way I am, and if you still have a button, I had my button hooked up onto pin 14. So I'm going to choose pin A1 as to where I'm going to hook up my potentiometer to it right now. So that'll be the third set of pins up from the bottom. So let me get this out of the way. And I'm going to plug this guy in just like that. Now mine lit up, yours probably won't. I should have actually cleared that code. In fact, maybe I'll do that right now. Because I was testing my code, so give it a moment. And there we go. So you are probably at a position like this, or maybe you had the 3-color going here. You've got some lights, but don't worry if your lights didn't turn on like mine did. All right, so let's make this work. Let's start off by making a global. Okay, so we have one pin where my potentiometer is hooked up. I'm going to do something I haven't done too much of with working with you guys. I'm going to make it a constant, which means it can't be changed. Doesn't really matter too much here, but we're going to make it a constant integer. It cannot be changed. And I'm going to call it my pot pin. And I'm going to set it equal to A1. Okay? So now my pot pin is going to be forever designated to pin A1. And then down here in my loop, we're going to keep it super simple to start off with. Let's just create a variable. I'll call it val, right, for value. I'm going to set it to analog read pot pin. All right. So now it's going to go ahead and read the value of the pot at that particular time and stick it into our variable value. So let's just serial.print value. And just to keep my serial buffer from not crashing, I'm going to make it a delay of, I guess 100. That should be plenty. All right. Well, I can't get any easier than that. So we got just 3 lines of code plus a creation of a global. So if I load this up, we should be able to get data. And as you can see, as I turn the potentiometer, I go from 0 to about 711, 711, yeah, looks like 711 is the best number I can get. Okay, so we get a variable reading from turning this potentiometer. I want to show you what it looks like with the graph too. It's kind of cool. If I close this and go to Tools and do Serial Plotter, you can see that I get a real nice graph of the data. All right, like so. Okay. We got the basic concept. Really easy to gather data. Now, let's take this a step further. I want to build a potentiometer meter. I want these things to scroll up and down. Now, you could think, well, I mean, I have those pins hooked up between 0 and 7. Okay. And we just did, I just demonstrated that when I turn the potentiometer, it goes between 0 and 710. Okay. Well, I could sit there and get on my calculator and think about it and fare a little bit. Say, well, let's see. I want to go from 0 to 7. Wouldn't it be nice if, 700 was, anything over 700 was to light up the 7th light, anything over 600. And I could do a bunch of if statements. If it's greater than 100, first light, 200, second light, 300, third light. In fact, seems pretty logical, doesn't it? And so I could create this complicated piece of software that would light those lights up as you turned up the knob and turn them down as it turns it off. But you don't have to work that hard because Arduino's already got it built in, and it just makes it beautiful. We're going to take that data, that 0 to 710 or 715, and we're going to map it. We're going to force it to fit within a very constricted space. And if you want to read about map, of course the textbook is awesome. You could also just jump to here and you can pull up, you could just search Arduino map and you'll find all kinds of descriptions about it. But ultimately, we're going to go from low of the value being read or manipulated to high, and then to low to high for what I want to put out. And I'll explain it as I do it. So let's take a look at this. I'm going to come over here. And I'm going to take now, I should have created a second demo. I'm going to paste it there just for the moment. And I'm going to copy this. And I'm going to paste it right there. I'm going to make a demo too. And now I'm going to take this piece of data right here. and move it up to here. Okay. So what we want to do is we want to scale our data in such a way that it goes between the low and high of our potentiometer to the low and high of our LEDs. So what do we want to work with? Well, we want to work with our value. Okay, so this is the variable we want to work with. It went from 0 and it went up to about 712. And I want to go to my LEDs. I want it to go to my 0 LED. And I want it to go as high as my 7 LED. Okay? So let's take this. When we map something, it's going to give us a value between 0 and 7. But I need a place to put it. So I'm going to create a variable. And I'm going to call it light. And I'm going to set it equal to the map of this data. Okay? So I created a variable, and I mapped my raw data from here to fit between 0 and 7 here. Now let's light it up. So I'm actually going to open up, I'm going to pause it and find that 8 LED piece of code because I don't want to just type everything from scratch. I'm going to copy and paste it. So I'll be right back. Alright, y'all remember this piece of code where we set all the pins to output, and then I did 2 demonstrations. You made the lights turn on and off as it went up down here. I'm going to set that side by side. Again, I could write these from scratch, but I like to copy and paste. I'm going to copy that setup so that way we turn all of our pins to output so we can light things up. And then I'm going to come down here and I'm going to grab one of these for loops. Okay? And I'm going to take this for loop right here. And I'm going to paste it right here. Okay. And then I'm going to make sure we have a closed brace that we can work with. Okay. So, let's talk about it briefly. We created a variable that's going to squeeze the data from 0 to 712 into fitting between 0 and 7. And I want to light the lights up. So I want to light the light up between 0 and that value. Because if that value is a 5, I want to go up to there. Make it less than or equal to. Okay? And if that value is a 7, I want to go all the way up the scale. And if the value is something else, I want it to go to that point. Okay? So this is going to make it light up to that particular point. So, well, you know what? Let's run this real quick. I'm going to minimize this. And let's load up. We'll make sure we run demo 2. And I can't remember. I think this is 0. Oops. Alright, demo 2. Ah, darn it, went the wrong way. Let's try this again. Alright, so watch what happens. As I turn the knob, it goes up beautifully. The problem is, it never goes back down. Ah, dang it. Super easy to fix. All we have to do is take and throw a delay in here of, say, 100 so that it lights up for a little while so we can see it. And then we simply want to turn off all the lights. So we want to go from 7 until it's greater than or equal to 0, and then make that a minus minus, and we want to make this low. So now it's going to turn on the lights, hold it for a short time, and then turn it off. So if I load this, you can see that it works great. keep in mind, I did comment that out.